Okay, good morning, my dear students. In the last class, we discussed about the basic concepts of that is the relation, which is ordered pair and Cartesian product of two sets. Today, we are going to discuss about the relations. Yes, okay. Now, relations. In the last class, I give a number of examples to form a relation. That is like the relationship between doctor and patients, isn't it? Teacher and student, parents and child, police and thief, and so on. Number of examples we see in daily life. And also in mathematics, that is the number m is greater than the number n, isn't it? P is a factor of q, A is a subset of B. Such an examples we can give number of examples, isn't it? Now we are going to define the definition of a relation. A relation R, that is the capital letter, a relation R, from a non-empty set A to a non-empty set B is subset of Cartesian product of two sets. That is the R is a means relation. R is a subset of Cartesian product of two sets A and B, that is A cross B. Means this can be written symbolically as R is a subset of A cross B. R is a subset of A cross B. That means relation is a subset of A cross B. Here A cross B means Cartesian product of two sets. I explained, we discussed in the last class, isn't it? That is the Cartesian product of two sets. Now we are going to discuss that is a relation R. A relation R from a non-empty set A to a non-empty set B to a non-empty set B. Now, if the relation consisting, that is the ordered pairs, if ordered pair x comma y belongs to R, ordered pair x comma y belongs to R means ಅಂದ್ರೆ ಒಂದು ಆರ್ಡರ್ಡ್ ಪೇರ್ ಅನ್ನೋದು ಆರ್ ಅನ್ನೋ ರಿಲೇಷನ್ಗೆ ಸೇರಿದೆಯಪ್ಪ ಅಂತಂದರೆ ಅರ್ಥ ಏನಪ್ಪ ಅಂತಂದರೆ ಎಕ್ಸ್ ಈಸ್ ರಿಲೇಟೆಡ್ ಟು ವೈ, ದಟ್ ಈಸ್ first element of the ordered pair x is related to the second element of the ordered pair y. Symbolically we can write x or y, x or y. That means x is related to what? Y. And the ordered pair x comma y does not belongs to R. The ordered pair x comma y does not belongs to R means x is not related to y. Symbolically we can write that is x is not related to y. That means this ordered pair does not belongs to R. R relationally ಇರಲ್ಲ ಅಂತ ಅರ್ಥ. Are you understood, all of you? Here this y is called as the image of x. That means in an ordered pair, second element of an ordered pair which belongs to the R is called as the image of first elements, that is the x. Are you understood, all of you? First element, that is the what? X. Now we are going to give one of the example, my dear students. Example. See here. One of the example. Consider set A is equal to set of all 1, 2, 3, 4, 5, 6. B is equal to set of all 6, 7, 8, 9, 10. 9, 10. We can write R is equal to, my dear students, we can write R is equal to set of all 4, 7, 5, 8, isn't it? And 6, 10. This is the relation. Why we call this as a relation? Because of this R is a subset of Cartesian product of two sets A and B. This is a subset of Cartesian product of two sets A and B. Hence we call as this is the relation, my dear students. Yes, are you understood? Now we have to represent this relation through one of the diagram, what we call as an arrow diagram. We can represent this relation through one of the diagram, that is called as an arrow diagram. See here, the visual representation of an arrow diagram is like this. That is this is the set A, this is the set B. Now the elements of A are 1, 2, 3, 4, 5, 6. The elements of B are 6, 7, 8, 9, 10. According to this example, R means here 4 is related to 7. Already I given 4 is related to 7. The ordered pair 4, 7 belongs to R means 4 is related to 7. That can be expressed as like this. Throw an arrow mark. 5 is related to 8. 5 is related to 8. And 6 is related to 10. 6 is related to 10. This is what we call as an arrow diagram, representation of a what? Relation through an arrow diagram. Are you understood, all of you? Yes. Now we have to move on elements of a relation. Elements of a relation, in which the first one is domain of R. The first one is domain of R. The first one is domain of R, my dear students. The first one is domain of R. See here. Domain of R means the set of all, listen carefully, the set of all first elements of, the set of all first elements of the ordered pairs, first elements of the ordered pairs in a relation R. Are you understood? The set of all first elements of the ordered pairs in a relation R. In a relation R, which is denoted as dom R. That is the domain of R, which can be defined as set of all, listen carefully, set of all x comma y, that is the ordered pairs x comma y, isn't it? Now I am going to write set of all first elements, listen, set of all first elements such that the ordered pair x comma y belongs to R, isn't it? The set of all first elements of ordered pairs, this belongs to the relation R. Are you understood? Are you understood? Now, from this example, domain of R, from this example, domain of R is equal to, we can write set of all first elements of the order pair means which are, that is the 4, 5, 6. Am I correct? 4, 5, 6. Isn't it? That is the domain of this relation R. Are you understood, all of you? The second one is, are you understood, all of you? Range of R. Range of R. My dear students, a range of R means the set of all second elements, of ordered pair in a relation R. In a relation R means range R, that can be denoted as like this, range R is equal to set of all second elements, that is the Y, such that ordered pair X comma Y belongs to R. Are you understood? Now, from this example, the range of R can be written as range R is equal to set of all second elements. Which are the second elements of this relation? That is the 7, 8, 10. Are you understood? 7, 8, 10. All of you are understood. This is about the range. Are you understood? That is the domain of R and range of R. All of you. Yes, all of you. Now we have to move on. That is the another element of a relation. We have to move on. Another element of a relation, my dear students, that is the codomain of R. Codomain of R. The whole set, WHOLE, the whole set B, what we call as codomain of R. The whole set B. That means whole set B, set consisting elements. The set of all elements which are belongs to the set B. What we call as codomain of R. Are you understood? That is the codomain of R. R is equal to the whole set B. Are you understood? Whole set B. Now, from this example, the codomain of R is equal to set of all 6, 7, 8, 9, 10. This is what we call as codomain of R. Are you understood, all of you? These are the three elements of which one relation. Yes, that is about the definition of a relation and representation of a relation and also elements of a relation. Are you understood, all of you? Yes. Now we have to move, my dear students, that is about the some of important points here. We need to express, that is the concept of relation, my dear student. We need some of the very, very important. See here, we know, my dear students, domain of R means the set of all elements 4, 5, 6. By observing domain and a set A, by observing, by seeing physically, domain of R means set of all 4, 5, 6, isn't it? From this example, the set A is equal to set of all 1, 2, 3, 4, 5, 6. There is a relationship between domain and set A. What we call such relation? That is, domain is first one. Domain is always subset of set A. Are you understood? Domain is always subset of set A. That means domain is always subset of the given first set. Given first set. That is the domain which is always subset of set A. That is the first set A. Second point. What about range? Range is also a subset of what? Set B. Range is a subset of set B. But what we call set B? That is codomain. That means range is always subset of B or codomain. Isn't it? Or codomain. That is, the range is always subset of codomain, my dear students. And also we know the relation is represented through two ways or two methods. ಅಂದರೆ ರಿಲೇಷನ್ಸ್ಗಳನ್ನು ಎರಡು ವಿಧಾನಗಳಲ್ಲಿ ನಾವು ಬರೆಯಬಹುದು, ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡಬಹುದು. ಆಸ್ ವಿ ನೋ, sets are represented in two methods. Yes, what are those? One is roster method, the second one is set builder method. In the same way, why sir? Since relation is also one of the set. Relation is also one of the set. The elements are in different forms. In relation, which are in ordered form. In sets, that is in directly standard form. Isn't it? Now, the relations can be represented through two ways. One is roster method and another one is what we call as set builder method or rule method. ಎರಡು ವಿಧಾನಗಳಲ್ಲಿ ನಾವು ರಿಲೇಷನ್ಗಳನ್ನು ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡಬಹುದು. My dear students, this is the method of representing roster. Isn't it? Here I have written list the elements, that is the list the ordered pairs and separated by a comma enclosed in a flower bracket. This is the representing, I think, which method means that is the roster method. Isn't it? And also we can represent in rule method also. In rule method also. For example, here, for example, that is the R is equal to set up all ordered pair 2, 3, 4, 5, 6, 7. This is one of the relation. This can be written in which one? Rule method or set builder method as R is equal to set up all ordered pair x, y such that, my dear students, such that y minus x is equal to 1. Isn't it? Y minus x is equal to 1 or the difference between x and y is 1 ಅಂತಾದರೂ ಹೇಳ್ಬೋದು ನಾವು. The difference between x and y is 1 ಅಂತಾದರೂ ನಾವು ಹೇಳಬಹುದು ಮಕ್ಕಳೇ. This is in roster method. That is the here x belongs to what? Domain, and y belongs to what? Range. And range. This is what we call as in rule method or set builder form. Are you understood? That is the relations can be represented through roster and rule method. And also, my dear students, we know another point. Generally, that is the relations are represented through two methods, that is roster and which one? Set builder. And also we can represent the relations, one of the diagram, that diagram what we call as ಆ್ಯರೋ ಡಯಾಗ್ರಾಮ್, ಇದನ್ನು ನಾನು ಆಲ್ರೆಡಿ ಹೇಳಿದ್ದೀನಿ. ಆ್ಯರೋ ಡಯಾಗ್ರಾಮಲ್ಲಿ ನಾವು ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡ್ಬೋದು. ಎಸ್, ನಾವು ಡಿಫೈನ್ ಎ ರಿಲೇಷನ್ itself, a relation itself. For example, consider a set A. Here I define the relation by using two sets, and also we can define a relation A on itself, ನಾವು ಡಿಫೈನ್ ಮಾಡಬಹುದು ಮಕ್ಕಳೇ. ಆ ಥರನೂ ನಾವು ರಿಲೇಷನನ್ನು ಡಿಫೈನ್ ಮಾಡಬಹುದು. isn't it? If I consider that is the A is the set 1, 2, 3, we can define a relation A itself on A. Itself on A. That is also what we call as one type of relation, my dear student. That is the stated relation on A. Now we have to move another very, very important point. The number of relations from a set A to set B. How can you define that is the number of relations from a set A to a set B, my dear students? See here, if the set A consisting m elements, that means this can be written as n of A is equal to m, n of A is equal to m, and set B consisting n elements, that is the n of B is equal to n elements. That means set A as m elements and set B as n elements. Then the number of relations, my dear students, number of relations from a set A to a set B, from a set A to a set B, set B is defined or is the formula to represent the number of relations from a set A to a set B is 2 to the power of mn. This is the formula used to find out the number of relations from a set A to set B if set A has m elements and set B has n elements. How, sir? We know the definition of a relation. Relation is a subset of what? Cartesian product of two sets A and B, isn't it? Now A cross B is also one of the set. How many subsets we can write for A cross B? Isn't it? That is depending upon number of elements of A and B, isn't it? Here also we know the formula, one of the formula, if A has m elements, then number of subsets of that set A is 2 to the power of, isn't it? In the same way, here also this is the formula we can write to find out that is the number of relations from a set A to a set B. This is we have to keep in our mind. 2 to the power of what? mn. If the set here A consisting how many elements? 6 elements. Here B consisting how many elements? 5 elements. That means we can write 2 to the power of 6 into 5, that is equal to 2 to the power of 30. 2 to the power of 30 relations we can construct for these two sets. Are you understood, all of you? Yes, my dear students. Yes, okay. Now we have to move on another concept, that is the inverse relation. Inverse relation, my dear students. Inverse of a relation. Inverse of a relation. Inverse of a relation is a relation which is denoted as R inverse. We denote it like this. If R is the relation, then the inverse of relation R is denoted as like this, and defined as, my dear students, R inverse is equal to set of all set of all ordered pairs y comma x, set of all ordered pair y comma x such that the ordered pair x comma y belongs to what? R. See here, R inverse ಅಲ್ಲಿ ordered pairs ಈ ಥರ ಇರ್ತವೆ, that is the ordered pairs y comma x. ಆ ಥರ ಇರಬೇಕಪ್ಪ ಅಂತಂದರೆ R ಅಲ್ಲಿ ordered pairs ಈ ಥರ, that means interchanging of what? Domains and ranges. Are you understood? Interchanging of domains of R to ranges of R inverse, isn't it? Interchange ಆಗಿರ್ತವೆ. ಅರ್ಥ ಆಯ್ತಾ? ಇಲ್ಲಿ ಎಲಿಮೆಂಟ್ಸ್ ಏನಾಗಿದೆ ನೋಡಿ, ಇಂಟರ್ಚೇಂಜ್ ಆಗಿದೆ, isn't it? This is what we call as R inverse. If R is equal to set up all ordered pair 5 comma 6, 7 comma 8, 9 comma 10, this is an R. This is an R. Then R inverse can be written as interchanging the elements of ordered pairs of R, that is 6 comma 5, 8 comma 7, 10 comma 9. This is called as R inverse. This is called as what? R inverse. That means, my dear students, domain of R inverse, which is equal to what? Range of R. Isn't it? Domain of R inverse which is equal to range of R. Isn't it? Range of R, and range of R inverse which is equal to domain of R, that is interchanging. Are you understood, all of you? Yes? Yes? Okay. This is about the what? Concept of relation. Yes? Under relation we discussed in this class. I explained in this class, that is the definition of a relation, representation of a relations, example, elements of a relations, that is the domain, range and codomain, and also inverse of a relation. Now with the help of these concepts, in the next class we discussed about the problems. Yes? Okay. Thank you very much.